Introduction to Vectors. Vectors are a key in understanding physical phenomena in that they give us a mathematical format for explaining, predicting, and calculating what happens in the physical world using equations created by scientists over several centuries. Let's begin by defining some key terms. For now, we will be solving problems in one dimension. Typically, we use the x-axis for that direction. Plus x will usually be to the right. Negative x would then be to the left. We could define it the opposite way, but unless specified otherwise, this is what we'll assume. We also can think about compass directions in terms of positive and negative. For example, north would be positive and south negative. The symbol for position is x. Displacement is the change in position. The symbol for change is the Greek letter delta, this shape right here. The change in position, or the change in x, is delta x. Displacement describes how far you are from where you started, regardless of how you got there. For instance, if you drive 60 miles from Pennsylvania to New Jersey, and we're going to label our starting position x0, it's right over here. So you start here, and then you go 60 miles from Pennsylvania to New Jersey. New Jersey is east of Pennsylvania. And then 20 miles back towards Pennsylvania. So here's where you were in New Jersey, 60 miles, and then you drive 20 miles in the opposite direction. And we're labeling the final position as x sub f. You have traveled a distance of 80 miles and a displacement of 40 miles, since that is how far you are from where you started. So what we have here is when you went this way, 60, came back 20, that distance is 80 miles. However, your final position is 40, and your initial position was 0. So you calculate displacement by delta x is x final minus x0. So in this case, it would be 40 minus 0, or 40. There's a difference between distance and displacement, as we showed on the previous slide. Measurements of distance can only be positive values, magnitudes, since it is impossible to travel a negative distance. Imagine trying to measure a negative length with a meter stick. It just would not work. However, displacement can be positive or negative, since you can end up to the right or left of where you started. So if you end up to the right of where you started, right, here's your final, here's your initial, displacement is positive. If you wind up to the left of where you started, okay, here's x0, that's where you started, then your displacement is negative. Each of the physical quantities we encounter can be categorized as either a scalar quantity or a vector quantity. A scalar quantity, such as mass, speed, and time, can be completely specified by its magnitude, that is its size, with appropriate units, such as kilogram, meters per second, and seconds. A vector quantity has both a magnitude and a direction associated with it, such as velocity and acceleration. A vector is drawn by starting at its tail, which is point C, with an arrow at the tip, which is point D, indicating the direction. The length of the line represents the magnitude of the vector. This vector is labeled with an arrow starting at the tail, which is C, and finishing at the tip. So you label it like this. And some people do this. You can have a double-headed arrow there, or just one. There are two other ways to label a vector, and they'll be shown in the next topic. When an object moves from point C to point D along the curving path, just follow the arrows there, it covers a positive distance that is longer than its displacement from point C to point D, as shown in the sketch. Right, your displacement is just the final position D minus position C, and that's represented by this vector here. And if the object continues from point D to point C along the path, it covers another positive distance. But the displacement of the object for the motion, and I'm going to change colors here, from point C to D and keep going back to point C, that displacement is 0. And our vector CD is the displacement of the object from point C to point D. So let me erase some of this. Edit, clear ink from page. The displacement is this vector. And if you go all the way around, your displacement is 0. You wound up where you started, but you covered whatever this distance is. Which of the following are vectors and which are scalars? Take a moment to complete the table, pause the video should you need it, and then move on to the next slide for the answer. Time is a scalar. It has no direction. It just has a magnitude. Distance is also a scalar, no direction associated with it. Displacement, you have a magnitude and direction, so that is a vector. Speed is just a scalar. That's what you would read on an odometer. It doesn't tell you which way you're going. Velocity tells you the magnitude of your velocity and also what direction you're headed. Example 1, drawing a vector. Draw vectors to represent A, a plane flying north at 500 kilometers per hour, and B, a wind blowing to the west at 50 kilometers per hour. So here's our plane flying north, and we typically say north is up. So that's 500 kilometers per hour, and the arrow is pointing in the up direction. Then the wind blowing to the west, which is typically to the left here, and that's at 50 kilometers per hour. The size of the vectors does not have to be exact, but should indicate the approximate relative size of the vectors.